All right, welcome back to pre-calculus. So we have a de Moivre problem. So we have a complex number. We have z is equal to negative 0.76 plus 0.65i raised to the sixth power. Use de Moivre's law. Use z to the sixth equals the absolute value of z to the sixth times cosine of n theta plus I sine n theta. Okay, so I do not excuse me, I do not want you to do it this way. Okay. Okay. 0.76 plus 0.65i, point negative 76 plus 0.65i, negative 0.76 plus 0.65i. I do not want you to multiply this out and like FOIL this thing out to the sixth power. Like, no, don't do that. I want you to use this absolute value, the modulus, raised to the sixth power times cosine of n theta plus I sine theta, n theta. Okay, so the first thing we're going to do is we're going to graph this because with drawing a picture, it's usually helpful. So I could say it's negative 0.76. That's going to be over here somewhere. And then 0.65i. So we're going to have this point right up here. Okay, so the first thing to do is this is negative 0.76, this is 0.65. Okay, in the imaginary direction, this is in the real direction. Okay, the first thing we have to do is figure out the absolute value. The absolute value is just how far away are you from zero? Well, I'm looking at this, and to me, it kind of looks like a triangle we have two legs. We have the adjacent side and an opposite side, and we have to figure out how to get this hypotenuse here. I think we've done that before. So what we're going to do is we're going to say that we have the modulus of z, or the absolute value of z, is equal to the square root of negative 0.76 squared plus 0.65 squared, and we're going to take that square root. Okay. Fortunately, I have a calculator sitting right here, okay, because we're going to need something like that. So we have 0.76, okay, how about 0.76 squared, okay, there it is, plus 0.65 squared. And we're going to go ahead and figure out what that is. Okay, it's 1.001. Of course it is. So if this was 1.0001, I believe. Okay, and we have to take the square root of this, 1.1231. So we're going to take the square root of this thing here. So second function square root, second function answer. That'll just pop in the rest, that last answer there. And I end up with 1.00045939. Okay, so we're going to call this 1. All right. Now, the next part of the problem is a little bit tricky. We have to figure out what this angle is. All right. And here's why I graphed it, because if we go ahead and do this, we could say that we know that the tangent is equal to the opposite over the hypotenuse. So we have tangent of theta is equal to, what's my I value? My I is going to be 0.65, okay, divided by 0.76. Okay, I put the negative out there just to make sure. I said that you guys can go ahead and do this in degrees. We're going to go ahead and check our degrees here. So we go back to mode. Okay, we can go down to degrees. There we go. There's degrees. Enter and quit this thing. Okay, so we're in degrees now. All right, what we're going to do is if we know the tangent is equal to this thing, then we would know that the inverse tangent, right, theta is equal to the inverse tangent of negative 0.65 divided by 0.76. All right, so we're going to figure out what this is. So we're going to say, oh, we need the inverse tangent of negative 0.65 divided by 0.76. Okay, and parentheses, I'm sure this is going to be a great number. We got negative 40 point, we'll say negative 40.54. So theta is equal to negative 40.54 degrees. Now, negative 40.54 degrees is going to look like it's down here somewhere, right? That's about negative 40.54. I'm looking at my original picture. That is not where this angle says to go. So what we have to do is we have to add 180 to this thing. So we're going to add 180 to this value so we could put it in the right quadrant. Okay, 139.46 degrees. We'll go ahead and say that. So theta is equal to 139.46 degrees. All right. So we have our angle and we have our modulus. Now we can say that z to the sixth power is equal to the absolute value of z to the sixth power times cosine of 6 times 139.46 degrees plus I sine of 6 times 139.46 degrees. Okay, this is what we actually have to figure out because we want to write this as z to the sixth power is equal to a plus bi. Okay, we knew we got the modulus to be 1, so 1 to the 6 is still 1. Okay, and now we have to figure out what this little piece is over here. So we're going to just go ahead and say we have cosine of 6 times, and we're just going to type this in, 139.46 degrees. Okay, we'll go ahead and hit the parentheses button. The calculator knows where this is actually going to be. Okay, we don't have to worry so much about, and even like not the fanciest calculators will know where this angle is supposed to be. We could multiply this out and then figure out what the actual angle is going to be, but the calculator will actually do that work for us. So let's take advantage of that. So I ended up with negative 0.45, so negative 0.45. Okay, and then we're going to do the same thing with our sine. And we can say, okay, we need the sine of 6 times. And I'm just going to say 139 point, well, I want, nope, clear that. Delete. Okay, we went 6 times, and then we're going to go ahead and say we needed 139.46 degrees. And I'll close my parentheses for that. And that'll be the problem for this one. We have with a positive 0.98929. So we're just going to say this is 0.289. So 0.89 I. Okay, so when we are all done with this whole thing, we have negative 0.45 plus 0.89 I, and that is my value for this z raised to the sixth power. Okay, so the cosine and sine, they've already taken into account all of this stuff. I just like to make sure that I put it in the proper fractions so that we actually get the right answer and we get the right area for this thing. So we ended up with negative 0.459. We're still going to be over here somewhere. Okay. And that's all you have to do with that problem. I'm not going to say you have to put it back into polar form. You don't. I just want it in a plus bi form. And that's how you go ahead and do that problem, right? I'm going to say thank you very much for watching the video, and I'll see you in the next one. Right?